All right, so Foundations of Math 30, this is the Chapter 3 review assignment. Those of you in my class here now, you've done this assignment. We're going to go over the answers to this. I'll show you how to do each one. And if you're watching this video right now, then why don't you pause the video here now and try and do question number 1 and 2. So this is the set theory review questions from your course. So pause the video right now and do question number 1 and 2, and then I'll go over the answers with you. All right, so if we look at number 1, it says this: list 5 elements in each of the following sets. So first of all, an element is an item or an object that's within some kind of set, right? So you guys are elements of my class today, okay? The elements in A here described is the provinces in Canada east of the province of Alberta. So we talked a little bit about this, just kind of roughly, if this is sort of Canada here like this, okay? We've got Alberta right here, and we've got to the east now, there's us in Saskatchewan, and here's Manitoba, and Ontario, and Quebec, and we've got Nova Scotia, and Newfoundland, and Brunswick, PEI, all that sort of stuff. So we only need 5, so we want to list 5 of these. You may have something like A equals, use the funny little brackets there. That's definitely a funny bracket. Okay, a little brace there. And so you can write like Sask, Manitoba, Ontario, Quebec, and so on. Nova Scotia. And then I guess that's 5. So you have 1, 2, 3, 4, 5. You only need 5, so any ones like that for A. Okay. Now B is maybe a little bit more complicated. We've got definitely some interesting notation there. So I'm going to zoom in just a little bit so you can see that. So the notation there is the set B has elements B such that B is equal to 10 times X, where X is an element of integers. So X could be anything like -1, -2, -3, -4, or positive 1, 2, 3, 4, 5, 6. No decimals, no fractions, nothing irrational. Just like basically whole numbers or natural numbers that are positive or negative. Those are integers, right? So for B, we could go like this. It's basically multiples of 10. So we could go B, we've got 10 times 1, 10 times 2, 10 times 3, and so on. So we could go anything like this. Now, I could also, if you want, you could also go negatives. So you go -10 if you want. You can go -40, anything like that. Positive or negative, X is an integer. So if it was 10 times a -1, it would be -10. 10 times -4 would be -40. So 5 elements that follow that pattern there. Any questions on one? Okay, got one. Awesome. Okay, let's take a look at question number 2 then. So represent these sets in a Venn diagram. Okay, so now Venn diagram, right? That's the diagram with the circles. So let's do that down here. Venn diagram. We're going to have U is the days of the week, A is the days you go to school, B is the days of the weekend, C the days of the week that begin with the letter T. Okay, so it looks like we've got U is the universal set. We're talking about all the days of the week, Monday through Sunday. All right, so A are the days you go to school. So let's do A. Yours should be something like this. Now, if you want to do Monday, Tuesday, Wednesday, Thursday, and Friday, you go right ahead. You can just abbreviate them if you want. B are the days of the weekend. Okay, now should B overlap with A? Are they, okay, they are, what do you call those sets that do not have any elements in common or can't? They are disjoint sets. Very good. So disjoint, they are not together, they are disjointed. So Saturday and Sunday, let's do that. Okay, so we're not quite done yet. We need to introduce C as well, the days of the week that begin with the letter T. Oh, so Tuesday and Thursday are in another set. So they're in 2 sets. Okay, so it looks like I'm going to have to do some rearranging. And if this was you, no problem. You just make sure you're doing this in pencil. And you would just move things around a little bit. And I'm going to move a couple things around like this. And I'm going to put Wednesday over here. And I'm going to draw another little circle that overlaps with A, and this is going to be, this is C. Okay? Now, should I have this circle outside A at all is the question. Okay. So what you're noticing here, and let me zoom in again so you can see this. Now this would be okay, not entirely correct. This wouldn't be the best Venn diagram you could make. Why? Because there is no option for anything to go in this space. So that is a space that is really non-existent. So why would we do that? So what you're going to do then is you're going to draw C as a blank of A. What's the word there? Is a blank of A. It is entirely inside A. And so what is it? It's a subset. Very good. Okay, so just, yeah, C, we're going to move, whatever, put C there. Okay, so something that looks like that. Are we good with that? And I don't think there's anything else we have yet to do on that. That's good. So that's the Venn diagram. Awesome. We recognize subsets and disjoint sets. Perfect. B says list a pair of disjoint subsets. Oh, no problem. A and B. Boom. A and B. A, comma, B, right? Now C, is each statement true or false? Explain. Okay, what does this little symbol mean? This is A something B. What does that little symbol mean? It means subset. Very good. So A is a subset of B. Is that correct? No, that is false. So I'm going to do a little F, I guess, for false. All right, what about this? C is a subset of A. Ah, that is true. C is a subset of A. Yeah. What about this? A prime is equal to B. So anything that's not in A is equal to the set of B. That looks pretty good, doesn't it? Yeah, there's no other values out here at all. So anything that's not A has to be, it is in B. So that looks true. You agree with that? All right, so that's true. And then let's see, what does this one say? The number of A plus the number of B plus the number of C equals the number in the universal set. Now, okay, I see some heads shaking. We have some overlap here for sure, so we definitely would be double counting some things. If we tried this out, I got 1, 2, 3, 4, 5. This would be 5. B would be 1, 2, okay, and C would be 2. So we've got 5 plus 2 plus 2 equals 9. Well, there are not 9 days in the week, so certainly that doesn't make sense. This would be true if each of these three sets were disjoint, okay? So if they were disjoint, that would be true. All right, so tell me if you had any issues there with question number 2 in the review. No? Okay, good. I liked the answers that you guys were given. Okay, if you're playing along here at home or watching the video here, why don't you take a few moments. Now pause the video and do number 3, and then I will come up with the answers here and show you those in a few moments. All right, so if you had a chance to take a look at number 3, so let's take a look at number 3 together. It says, Irwin surveyed 35 students about their favorite fruit. She recorded, sorry, that would be Aaron. Aaron, Irwin. That's Aaron. I've never seen it spelled like that before. That's interesting. Draw and label a Venn diagram to represent this data. Okay, so we've got some favorite fruit here, list of favorite fruits, and we've got numbers of students. Okay, so there's 35 students, so I'm going to draw a rectangle here. This is the universal set. There's got to be 35 students, right? The number in the universal set has got to be 35. That's what we know. So 35 people have to go inside this big jumbo, rectangle right now for the set. So the Venn diagram, it looks like I'm going to have a circle in here for oranges. Oh, okay. So oranges. Now there's 14 people that like oranges, so I'm going to put 14 in there right now. 14. But there are also people that like apples as well. So there may or may not be overlap here. There could be some that like both, so I'm going to overlap that. Now we could figure that out right away, so I'll show you that in a second, right? We could figure out if there's some overlap by adding up these numbers, right? If the sum of these numbers is greater than 35, we know that we're double counting some people in this list. If it adds up to exactly 35, that means each of these are disjoint sets. Now we've got apples, oranges, and then look at this third one, is neither oranges nor apples. So we don't have to have a separate circle. We could just put the rest in the space over there. Okay? So really we only need 2. So 8 people are going to go out here. We know that. Okay. All right. So if we add these up, what do we have? That's 48 looks like. 48. Does that look right? 20, 30, 48. So 48 minus 35 is 13 people. Now, what does 13 mean? 13 means that we've counted 13 people twice, right? We've counted them once in the 35, but then we've counted them again by saying that, hey, this person likes oranges and then this person likes apples. So there's going to be 13 that go right here. So what you need to remember is that when you add a 13 in here, really you're just shifting this number around. So this 14, you have to take the 13 away and show a number 1 there, because there still has to be a total of 14 inside this O circle, okay? And also we need to take 13 away from here, which that's 13 left over. So 13 like both apples and oranges, and 13 only like apples. Now if we add these numbers up, 1 plus 13 plus 13 plus 8, that's going to be 27, and 8 is 35. So that is equal to 35. So that's perfect. Okay? So 1 likes oranges only. All right. Determine how many students like oranges or apples. Okay, so oranges or apples. That is, or is both circles. That's or right there. This is or. So we've got 13 and 13, and 1 is 27. Did you get 27 for B? Mm-hmm. Determine how many students only like oranges or only like apples. So if we're looking at that number, we're looking at only oranges is 1, as I mentioned. So only orange equals 1. Only, I'm writing this as messy and as fast as I can, only apple has how much? 13. Perfect. Okay, so that number's gone now. That number's gone. All right? And that's number 3. That's number 3. Okay. So you should know how to do that. Should know how to do that. All right. Excellent, excellent. Okay, let's move to the next one here. So let's take a look at number 4 first. So again, pause the video if you're watching this. Take a shot at number 4. When you're done, press play again. I'll show you the answer. Okay, so number 4. Did any of you guys have trouble with number 4? Was number 4 give you any trouble at all? Okay. Well, let's just see. Describe 2 sets A and B, which each of the following formulas would apply. Okay, so we need to describe 2 sets. So that means just tell me what kinds of things would apply here. So the number of A in union with B is the same as adding up all of A and all of B. So union is either or, okay? So if we can just simply add straight A and straight B to get the union, that means they are what? What are those sets like? They're disjoint, right? Because there's no overlap. There's no overlap. So these are disjoint sets. So you can write that for A. A and B are disjoint. Describe 2 sets. A, B are disjoint. Now, I'm not actually sure how you interpreted this, but I would like us now to think of 2 actual sets in real life that would be disjoint. That there would be no overlap between. So can anyone think of anything? Shouldn't be hard. Set A is this, set B is this. Okay, you said insects and birds. Okay, and then you said, oh no, they both fly. Okay. Okay, so if we're talking about flying organisms and insects, there would be some overlap there, right? But if we're talking about insects and birds, those could be classed differently. Now, the mosquitoes around here get pretty big. They look like birds, but they're not. So insects and birds, I think that would be fine. Now, I'm not a biology major, so sorry if there's any bio majors out there that want to disagree. You can leave a comment. Call me. But anyways, I don't think we got any birds and insects. There's no one organism that is both a bird and an insect. I don't think that's possible, okay? Okay, anybody else? Anything else? Sorry? Weekends and school days. Oh, that's interesting. That is interesting. I know for a fact that in parts of the world, and you may know this too, the parts of the world, kids go to school on Saturday. Yeah. Yep. Lots of kids do. So that leads me to B. Thank you very much. That leads me to B. Okay, now B, the number of A union B. If we were to take all of the elements in A and the number of all of the elements in B, but then we would have to subtract the intersection part. This is describing two sets that are not disjoint. Okay, so these are A and B are not disjoint, or they overlap, you can say. Okay, wow, I'm super messy today. Look at that. I should have been a doctor. Wow, can't read their writing. Anybody tried to read a doctor's like prescription or something? It's like alien. Give me alien something. I don't know. Whatever this said. I don't know. Okay, so your example was weekend days and school days. Now, for some people, they go to school Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, right? So that could overlap. Now, for us here, we don't make you come to school on Saturday or Sunday, right? So those are technically not school days. I would agree with you. Here, that would be fine. So let's see, students in this school and girls in this school, okay? So there are some students that are girls. They're in both circles, and some students that are not girls. So they are not in the same circle, but those would be some overlapping there. Okay. Okay, I hope you got that. Now, number 5, we've got 2 more left here in this review. 2 more left. Number 5 is a principle of inclusion and exclusion question. So I will direct you to, for number 5, if you haven't started this yet, you will want to go to the 3.4. You want to watch that video, go ahead. But in keep going. 3.4, here we go. In questions like this, we are using the principle of inclusion and exclusion right there on your screen, down here in your textbook. I do have another somewhere. So here's one as well. This is a type of question where we use this long formula, principle of inclusion and exclusion, right here. So this is the one you're going to want to use. If you are unfamiliar with that, you need to learn that. And also, I will leave this up on the screen if you want to study this type of question. But we are going to get back to the review question, and this is the formula that you need to use. So for question number 5, pause the video right now, give it a try, see if you can come up with, this is the question, how many campers received instruction in all 3 art forms? So you got to figure out where that is in the Venn diagram and how to use your principle of inclusion, exclusion. That's going to be the easiest way to do this question, okay? So pause the video, give it a shot. All right, question number 5. As we mentioned, principle of inclusion and exclusion. I will go back. Here we go. This is the principle right here. And I'll copy this. And I will drag this over down to our other page. And I'll just pop this maybe above there. Let's see if I can, let's see if I can do it. Let's see. Oh, yeah. Nice and cute right there. Okay. So we'll keep that in mind while we do this question. So, oh boy, here, let's try my French. Le centre de développement musical, le girandole, and le unithéâtre. How was that? Was that bad?
Yeah.
I wasn't trying to make fun. It was bad? I thought that was good.
No, it was.
Okay, I'm sorry if I've offended any actual French-speaking people, but this is the way that I would, this is without effort. This is the way I would read this without effort. Le Centre de Développement Musical, La Girandole, and La Uni Theater. See, that's worse, isn't it? Was it better before?
Yeah.
Okay, yeah, it was better before. It was terrible. Okay, can we keep going? Cut. Okay, I'm gonna cut that out of the video, probably. Maybe not, too much work. Offer a summer camp every year in Edmonton. At the camp, multi-arts students can receive instruction in at least one of the following: singing, dancing, and acting. Okay. Of the 56 campers, here's the list of what we've got. 35 were instructed in singing. Okay. So it looks like we've got N of, let's say S is singing, is 35. Okay. 38 in dancing. Oh, the number in dancing is 38 in dancing. And 33 in acting. Okay, so I see, boom, boom, boom. I see those right there. We're going to put those in our formula. Okay, what else do we know? 21, we're instructed in singing and dancing. Okay, so that's the number of singing and dancing. Okay, that's 21. 18, we're instructed in singing and acting. So the number of singing and acting is 18. And 23, we're instructed in acting and dancing. So acting and dancing is 23. Okay, so do you guys agree with those numbers? I've got those settled right? Okay, so notice up here, what we have is we have number of A union B union C. So that's really, I'll change my color here, the number of singing or dancing or acting. So that's everybody combined. And we actually see that right here. There's 56 campers. Now, you're not going to be at the camp without doing at least one of those three things. So that's everybody. Okay. And I'll put that underneath here, 56. Okay, equals. Now, what's next in this? Well, the number of singing, right? The number of singing we said was 35. So I'll put that underneath there. And the number of dancing, okay, that's 38. And the number of acting, that's going to be 33. Okay. So the rest of this now, look at this. We have to subtract the number of singing and dancing. Because remember, if we have three, like a Venn diagram like this, okay? So this is the reason why we do this. Because as we count, and I did this in the lesson before, as I count, let's say, the singing one, all this, I'm actually double counting when I count the B one. So the B, see, I'm double counting this area right here. So I have to subtract it off. Okay, and we're going to do that for all of these areas and so on. So watch that video or review that lesson if you need to. But when we add up multiple sets that are not disjoint, we are double counting. So we're dismantling our double counting here. Okay, singing and dancing. So what's that going to be? Where was that? 21. We also need to subtract off the number of, let's say, singing and acting, which is 18. We need to subtract off the number of acting and dancing, which is 23. And then finally, because we've subtracted so many things away now, we have to add in the middle part again, because we've actually eliminated that totally. So we have to add in the little part. Oh, what's the little part? Well, the number of singing and acting and dancing is the very middle part, and that is unknown. We do not know. That's this question right here. All three forms. So that's the middle part. So guess what? This is a big fat X right there. Unknown. And once we get to this point, then we go ahead and we solve for X. Okay? So I'll just get on my calculator and, whoops, I guess I can't do that. So this is how you do this on your calculator. You could move each one of these terms over individually, or you could just say, hey, I've got 56 over here. And I'm going to bring over this 35 by subtracting it. Subtract 35. I'm going to bring this 38 over by subtracting it from both sides, minus 38. And the 33 as well. It's a plus over here, so it's going to be a minus on the other side, minus 33. And because this is a negative 21 over here, I'm going to add 21 to both sides, so plus 21. Because I got a negative 18 on the right, it's a plus 18 on the left. And that's a minus 23 over here, so it's a plus 23 on the other side. So now I've combined everything over here on the left, and what we're left with is just an X only on the left, because we got rid of all of these things, and we have a total of 12 on the other side. And that should be your middle number. That's the part, that's the intersection of all three. And if we add all this up on the right side, we should get 56, all the campers. Okay? So, principle of inclusion and exclusion, very, very important. You need to know this. I think that was originally from 3.4. Okay? Now, 3.5 and 3.6 is the last section, and you guys have a quiz coming up on those two sections. So we just have one question that is a review of that. But in here, we have some definition of some words. So for number 6, again, if you haven't done number 6 here yet, go ahead and take a moment to do number 6, and we'll show you, we'll go through the answers here for number 6. All right, so here we go. If a number is negative, then it is less than 0. Okay, so what is the hypothesis of this conditional statement? Okay, so the hypothesis comes right after the if. So a number is negative. A number is negative.